So you see I'm already in the right corporate identity here. Again, Open Industry 4.0, Open Edge Computing. We continue where we stopped the last presentation. So now we want to hear some details of layer 2 of the reference implementation. So we see the reference implementation once more. We see the different blocks there, but also, of course, something from layer 1 to layer 4. But I don't want to explain too much of these layers. So we start our presentation right here. We have a closer look to layer 2, which is heavily using OPC UA technology, because this can solve our challenges to be interoperable with others. So the layer 2 of the reference implementation is basically the open edge computing. So there can be some work be done. It's a scalable platform, and it connects to IT on the one side and to IT or cloud, of course, and to OT on the other side. Talking about layer 2, of course, we do have assets on the shop floor which need to be identified. So we want to identify them. We want to read data from them. Maybe we want to write data to them, depending on the use case, of course. We might have the connectivity layer. I mentioned that already. Think about Profibus interfaces or think about CAN interfaces. So you might need some Ethernet device in between to make it accessible from a standard open edge computing platform. Standard means, of course, you can have a special edge gateway with Profibus interface, for example, but maybe it's just a standard gateway with Ethernet interfaces. So the platform is there for evaluating and aggregating the data and doing something with that on this level. So the open edge computing is basically based on an ARM or x86 architecture. Of course, others would be possible, but if you see later on, this is what we concentrate right now. If the market changes and we see an RISC-V or we see MIPS or whatever, other technology coming up, of course, if all the building blocks are cross-compiled to that platforms, that would be also possible. But for now, ARM 22, 36 and 64, sorry, and x86 64 is the main platforms. So talk about the footprint. Actually, the footprint is really up to the use case. So we might have solutions where we need a 19-inch rack with some blades inside, and we might have other solutions where basically the calculation power of a Raspberry is enough. So of course, it's really scalable. So it's up to the use case and up to the industries what kind of hardware is used. At least Ethernet interfaces must be there, as more as better as usual when we talk about gateways. We are driving that on Linux. We are not talking, it's not important which kind of Linux, so you can take your standard Linux platform, because we could drive that also with Windows, for example, but on the next step you see we are talking about container environment, and not every Linux container is working on a Windows environment without any problems. So this is why we decided we use Linux as an open operating system. So going into the layer 2 of the Open Industry 4.0 reference architecture, we decided to have a containerized environment to be flexible enough to drive all these different use cases by just deploying different containers which are basically following a microservice architecture. So container environment as an industrial standard to run containerized Open Industry 4.0 Alliance applications. Goes further with these applications has a defined interface for interoperability. So we have an OI4 interface in these containers. Why did we choose containers at all? Because containers, containerized applications are scalable, cascadable, and lightweight. So the runtime is quite easy to handle. I used OI4 Allianz quite often on this folio. Of course, it can coexist with other containers. So it doesn't mean if you decide for OI4, everything has to be OI4. There's always, it's not only white and black. There's a lot of gray in our world. So of course they can coexist. This is one of the reasons, by the way, why we took standardized message bus. The standardized message bus is based on MQTT technology because it's widely used in that kind of applications. So there are many frameworks out there with a similar concept which are working with MQTT and Docker. So of course they can still exist even on the same platform, even on the same bus, because the bus is not only doing the messaging as we want, they also can do like proprietary messaging or messaging following other standards. Compared to MQTT, we have a well-defined topic structure. This is actually the main difference. And this is also why we are not saying we are OPC UA PubSub JSON, because OPC UA PubSub JSON doesn't care about the topic. And this is the reason why, and this is the answer to your question, this is the reason why we cannot call it OPC UA messaging bus, because that wouldn't be true. But we standardized the communication semantic-wise, so we are using as payload OPC UA PubSub JSON, and this is very important for us, and this actually should be enough for seeing the ground concepts, but now we're going more into the details for the message bus and MQTT and OPC UA PubSub JSON. Oh, sorry, I forgot. Of course, we have containers, so maybe we should have applications also. So we have containers and applications, connectors and applications. You see already some of them are written here. We have, for example, a Profinet connector. We might have a proprietary connector down there. So connector to the OT world might provide interfaces to all these proprietary protocols. They are not really proprietary, they are all open, but to all these different protocols, these are all different domains. So somebody who wants to connect to these data from the cloud, they might have knowledge about one of these field buses because they had to in the past, but they don't want to know all these different field buses. So this is why you can encapsulate the field bus in one of these containers. So the container basically aggregates the field bus and the agnostic information from the field bus can be seen or can be provided to the message bus. This is the ground concept on that side. Of course, we also have connectors to the cloud or to the IT. Same facts accounting there. So, of course, in the cloud connectors, for example, you have to deal with security much more as on the field. This is like a traditional or historical thing, may change in the future, but right now this is also quite a pain for the OT guys because they have to deal with things which they are not used to. So these connectors can solve these problems because they are like separated from the rest. And if these bricks fitting to each other like Lego bricks are doing, so you really have like a micro service architecture. Of course, you can also have applications which aggregate or compute some information, like you could have a dashboard application up there or an AI application which is doing something with the data which are provided on the message bus. Yeah, most important thing, of course, and this is also one of the reasons why we used OPC UA PubSub. OPC UA servers and OPC UA clients, of course, playing a big role in this architecture, because they are already there, at least in Greenfield, and we still think that will grow a lot during the next years, of course, and this is why we definitely want to have a bridge in this technology. There's no way going around OPC UA client server. So a protocol adapter, for example, with OPC UA client could reach information from an OPC UA server in the shop floor. This is one example. Another example, of course, we could have an OPC UA server representing the content of the message bus to the outer world, to every OPC UI client with the right credentials. And this is now the point where we go to the, where we leave the 10,000 feet. We go a little bit more into the details. First of all, I would like to explain you why we took the message bus as it is today. So we took MQTT as a communication protocol because several edge platforms are using it already for interoperability. The protocol is lightweight and easy to use and to integrate. It's very fast, so there are a lot of reasons why MQTT is so successful, but it also has a minus out of my view, because MQTT doesn't care about the topic structure and about the payload. So all the things all the time which you save in the beginning of the project, you spend later on when you define the payload and the topics. So again, this is one of the reasons why OPC took care about that, and also why the OI4 took care about that. So the difference between standard MQTT, or actually it's still standard MQTT, but we added some guidelines to it. So we defined OI4 messaging over MQTT following a schema. So this schema is evaluatable, so that means you can make a schema evaluation over the topics. You can reach information from other applications just by knowing the topic schema. So it's easy for you to use the wildcards on the right position to get all the information from the message bus, which is important for your use case. So you see, for example, we do have a namespace here, OI4. So that means, of course, other traffic can be there also. So it's not an OI4 message bus. It's a message bus also used for OI4. And then you have these fields which explain like the topic structure, and you can evaluate that. And like, for example, if you know you have a special source, then you can ask for the source and get the information from that, or you can even subscribe to topics which you might have seen or which you might want to see on the message bus. Something which doesn't belong to the topic, but for some reason I left it here. Of course, topic is defined now. It's not defined by the OPC Foundation for some reason. This is the reason why we defined it. But the OPC PubSub JSON as a payload is a very big key feature for us. And this is what I would like to go deeper in the next 2 minutes, I guess. So MQTT over, OPC UA over MQTT. What does that mean? We wanted a self-explaining payload. So we looked around, of course, what does the market has. For example, we have seen Sparkplug. We discussed it because it's lightweight, it's easy to implement, and it has a small but quite good definition. But it didn't solve all our problems. So we looked again, and we saw there is OPC UA PubSub, but neither did that protocol solve all our problems. But we chose it anyway, because first of all, it has a good foundation for all our use cases. also the concepts just fitting to our industries. So of course, it doesn't matter who you talk to, everybody knows OPC UA. So as more we are using OPC UA technology, as easier it is to implement ourselves in these fields. And then, of course, a lot of members of the Alliance are also members of the OPC Foundation. I'm one of them. So Hilscher is also a member of the OPC Foundation. We have quite a big OPC server development team developing stuff for our processors, for our microcontrollers. So we took the bet OPC specs will solve our upcoming problems. One of the biggest was, for example, PubSub actions. So it's like calling methods over the message bus. PubSub actions is the new word for that. That wasn't existing like 3 years ago when we started with using OPC UA. Yeah, and I mentioned that already. OPC UA client server is a very big, it's an integral part of the addressed industry. So of course we want to address the easy integration of client server architectures also in OPC, also in the message bus infrastructure. So the question is now, is this really OPC UA what we are doing? Because we started 3 years ago, and some rumors in the field says, yeah, this is not really OPC what we are doing. So let's see what we did. This is an original screenshot from the guideline version 1.0. It's more than a year old, and in this you see some funny keys which are not mentioned in part 14. So the OI4 detected missing functionalities, and we had to solve problems. So we said, okay, seems not to be solved, so we have to solve it by ourselves. We add keys for our use cases. And then another thing, you see some camel case written information here, major version, for example. There are many more when you go through the guideline, but these are 2 of them. And indeed, the OPC Foundation says no, this has to be a Pascal case. But in part 14, they are still camel case. So we just adapted the notation as it is in the specification, which was wrong. But hey, this is why we are here. This is why we are talking. Communication is not always going the right way. This is why OPC UA exists. And this is why we talk to each other. So during the SPS fair, some technical guys from the OPC Foundation and some technical guys from the OI4 talked to each other. We had a beer actually. And in the end, we found out, yeah, I mean, we talk about the same things. We have the same goal. And this guy promised me they don't want to make a better OPC UA. This is absolutely not the case. So members of both organizations joined the OPC UA PubSub prototyping working group. Actually, there was one big meeting with really quite a lot of people. Matthias was holding that meeting. I was one of the participants, beside many others. It was a quite international meeting, and we found out, yeah, I mean, the first 15 minutes was a little bit not so easy, like talking how to talk to each other. But then in the end, we found out, yeah, of course, again, we have the same goal, and many of the problems we have detected may have been solved already, but not yet documented. This was quite a surprise for us, but also we were quite happy. So what we have done is we not so long after the Hanover Fair, we already wanted to release the version 1.1 of the guideline. So we couldn't solve all problems, but at least the low-hanging fruits we solved. So the major version and minor version in that example, again, it's many other examples in the guideline where we have solved that. Of course, we also had to solve it in the source code in our reference implementations. So it was quite a lot of work, but still low-hanging fruits. So the OI4 changed the notation to Pascal case to follow the OPC Foundation's rules. This is what we have done already. We also, again, had a look on these special keys which we had. There was not enough time to discuss all the details with the OPC Foundation, so they are still not compliant, but we evaluated the missing functionality and we found out basically most of that stuff is already implemented for the binary protocol, but not yet documented for PubSub JSON. So it's not yet implemented in that part of the specifications which we have, what we have read. Sorry. So therefore, again, we discussed that, and it looks really quite promising that, for example, the dataset writer name and writer group name can solve the problems what we have with filter and source. There are still some discussions going on, but it looks promising. I'm quite sure the next specification will not have these keys anymore. And then we also talked about the correlation ID. The correlation ID is because we talk about microservices, and if one microservice triggers another one, you should know which microservice it was, and this is why we have this correlation ID. OPC UA doesn't have this yet. So we discussed that, and actually Matthias had already an idea. I couldn't follow that completely, so I have to understand it a little bit better. But we have some common understanding, and I'm quite sure we can save that on a way which makes it OPC UA PubSub JSON Part 14 compliant. So this is really OPC UA PubSub. With the upcoming guideline, we don't know yet if it will be the version 1.2 or version 2.0. It's not yet defined. But with the upcoming version, we will purely use OPC UA PubSub. So the network message and dataset messages, and of course I forgot to mention it here also, the metadata will be OPC UA compliant. This is what our work group promised, and this is why I'm staying here and saying that. We also want to adopt the PubSub actions because we need them. This is also something we have a prototype doing that on our way. We showed that to the working group. They said, yeah, this is a straightforward way, but we had some problems there. We were thinking about that too. So they have a better idea now, and if this is coming to the next standard, we also want to adapt these mechanisms for calling methods over the MQTT message bus. There are some other minor things, like for example pagination. Like if you have a very large MQTT message which is longer than allowed for the message bus, so you need to paginate that somehow. I have heard the binary protocol has already a solution for that. I don't know that solution yet. I wasn't deep enough involved, but this is also something we have to adapt somehow. So there are little things we have to talk. But this is a reason why we will all join the new working group. I just found out the old prototyping working group gets paused, and there's a new one which is on the way to start their work. And in this group, we, among other organizations which also use MQTT, we want to discuss exactly these things to bring part 14 further and bring the usage of part 14 further with the use cases we can add to the standards. So in the end, Open Industry 4.0 Alliance is fully committed to OPC UA, and we want to use the PubSub JSON compliant to part 14. This is important. By the way, these are my kids. I was looking for a picture which I can use freely. I didn't find one, so I made it extra for you. And my kids are speaking Finnish, and they are much better than me. So I know only yksi olutetti, which never worked, by the way, for some reason. Yeah, so thank you a lot. I'm open for questions.